Hello student, in the previous videos we have discussed about how we can design the input and how we can design the output. Now we are going to discuss about how we can design about the databases or what is the importance of designing the database. Here you can see ensuring the data can be shared among the users for a variety of applications. Maintaining data that are both accurate and consistent. So maintaining the data is not only about making it accurate, it need to be also consistent. And also we need to ensure that data can be shared among the users which are using the information system through the variety of applications. And ensuring that all data required for current and future application will be readily available. So whatever data will be required, it might be for current or it might be for future applications, should be readily available. So that is actually we have or you have gone through or you might go through in future or in past that about database management system, DBMS. This is the heart of a database, is the database management system, which allows the creation, modification or updating of databases, the retrieval of data or generation of reports and displays like that. We can vary such a kind of thing using database management systems. And also we need to know about those things, while we design the databases. Like we need to know about what are the data. Here you can see what is data. It is important to understand how data is represented before considering the use of files or database approach. In this section, critical definitions are covered, like what is reality or what is data or what is metadata. The real world detail or real world information will be referred to as reality, and data collected about people, places or events in the reality will eventually be stored in the file or database. To understand the form and structure of the data, information about the data itself is required. The information that describes data is referred to as metadata. So information about the data itself is required sometime. So here you can see, in reality we try to create the entities so that we can store the attributes of the reality. Then we can create the record occurrences to store those information of entities and data item occurrences. And also in the metadata we try to record the definition of those data or information about those data. So that is the relations among the data, reality, data and information, or you can say metadata. Next, what is entities? Any object or event about which someone chooses to collect data is an entity. So entity might be any object against which we can collect some data. Next, what is relationship? Relationships are association between the entities. Relationships are association between the entities, and there might be different types of relationship between any two entities. Like here you can see example of ER diagram. There are different type of relationships. Like first one is one-to-one relationship, means employee is assigned to a office. Product has a product package. So this is one product has a one product package. One employee has a one office. But there might be exist also one to many or many to one relationship. That is, one physician might treat lots of patients, means one to many, and many employee belongs to one department, that is many to one. And also there is many to many relationship, that is various students or lots of students might take lots of courses. And also lots of salespersons serves lots of cities, that is also many to many relationship. So in entity relationship symbols, these are the meanings. This is the entity symbol, a class of person, places or things. This is associativity and entity. If it is associative, used to join two entities. So this is used to join the entities. It is attributive entity, used for repeating groups. This is one relationship, exactly one relationship. This is too many relationships, one or more relationship. to 0 or 1 relationship. This is 0 or more relationship. This is more than 1 relationships. This is 1 or more. This is exactly 1. This is 0 or 1. This is 0 or more. This is more than 1 relationship. So here one example of entity relationship diagram. Here we can see this is prescription belongs to this treatment belongs or includes prescriptions, or you can say physician treats patients, or patient is taken care by physician. Patient subscribes to insurance carrier, or insurance carrier insures the patients. Patient experiences treatment. Patient is given to treatment. Belongs to treatment is belongs to prescription, and prescription includes the treatment. And here one thing is that you can see from this direction that is exactly one physician exactly one patient treats, but patient might consult with one or more physician, taken care of by one or more physician. Here again you can see physician subscribes to one or more insurance carrier, but one insurance carrier exactly insures one patient only at a time, and again patient exactly one time experiences the treatment, but treatment might be one or more than one is given to the patient. That is this, and all these entity has different values, datas. Physician name, that is the main part. Physician address, physician phone number, specialty. Patient name, patient address, patient phone number, date for visit, carrier address, plan description, like that. So in this ER diagram we can understand how they are related, how their relationship is related. So attributes are important. Attributes, some characters of an entity. There can be many attributes for each entity. For example, a patient can have many attributes such as last name, first name, street address, city, state, so on. Like that way for other item also. And also there is another term like data item is also used interchangeably with word attribute. Records also there. A record is a collection of data items that have something in common with the entity described. Figure 13.6 is the illustration of a record with many related data items. So here you can see this is the entity, what are the data item and what value can be there with every entity. Typical values assigned to data items may be numbers, alphabetic characters, special characters, combination of all three. So what type of data can be there? Numbers, alphabetic numbers, special characters, and combination of all three. Here you can see a record has a primary key. This is the primary key, and may have many other attributes, and this is the complete record of attributes, and it should have a primary key. And what is metadata? Metadata are data about the data in the file or databases. Metadata describes the name given and the length assigned to each data item. So this is actually, metadata is actually the information about the data, or we can say it describes the data, it defines the data. Next, a file contains groups of records used to provide information for operation, planning, management, and decision making. The types of file used are discussed first, following by the description of the files. There might be different type of files. File types like master file. Master file contain the records for a group of entities. The attributes may be updated often, but the records themselves are relatively permanent. These files tend to have large records containing all information about the data entity. There might be table files. A table file might contain data used to calculate more data or performance measures. And what is transaction file? Transaction file is used to enter changes that update the master file and produce the reports. So three types of data are there. One is master file, One is table files, where the actual information is there. Master file contains the group of entities. The attributes may be updated often. The records themselves are relatively permanent. These files tend to have large records. Although the analyst is free to arrange the data elements in a master file in any order, a standard arrangement is to place the primary key field first, followed by descriptive elements, and finally by the elements that changes frequently with the business activities. And there is also table files. A table file contains data used to calculate the more data or performance measures. And again, transaction files, that is about how we are using the master files, how the transaction is going on with the master files. So here you can see data item like this, values are like this. Metadata includes a description of what data value each data item looks like. So this is a metadata. This metadata contains all the data item, what are the value they contain, what are the possible values they can contain, and what are the fields like this, description of those fields. What is N means numeric, A means alphanumeric, D means date, dollar means currency, M means memo. So like that, 7.2 means that the field takes up 7 digits, 2 of which are right of the decimal. Special formats for fields may be specified for date like variable. So this is database design includes like this. This is the user reports, tabular outputs, so it creates a tabular format. So database design includes synthesizing user reports, user views, and logical physical designs. So first what it does, try to gather the user inputs, okay, using forms or other things, tabular outputs, graphs. So it outputs these tabular outputs, it creates the tables from the information of the users. Then it try to creates a views of user schema, how we can see that the table, how they are related, how they can be associated. And then this is a conceptual schema, then it can be stored in the internal schema, that is physical design model of the database. So this is the layer of the designing purpose, how we can design the database storing part, how we can synthesize the databases. First, the user inputs that can be transformed to tabular format, and that can be transformed to the conceptual schema or logical schema like the ear diagram. Then that can be converted to the physical schema or internal schema or physical design model of databases. And this is the real scenario of the storing process. Here one example of relational data structure. The data are stored in many tables, like this is one table, this is another table, this is another table. So then we try to use, or we try to reduce the things, we try to do the normalization. There are 3 steps of normalization. First step is that usually the general information are taken from the users view, unnormalized relationships. Then we try to go for normalized relations, 1 NF. Then we try to go for second NF, second normal form, and then we go for third normal form. There is also called BCNF or fourth normal form, but we don't take because third NF, 3 NF is enough. So what is first NF? That is removing of repetitive groups. If there are items or groups or information which are repeating, so then it will create redundancy in case of data. So we need to remove those repeating groups. Then we need to remove partial dependencies. If is there any data that is partially dependent on other data, then we need to remove those partial dependencies by including more data or including more variable to remove those partial dependencies. And again we need to remove transitive dependencies, like suppose A is dependent upon B and B again dependent upon C, then obviously in transitive relation A is dependent upon C. So those dependencies should not be also there in a data sets or databases. So we also need to remove that thing to normalize the data. So after removing all these things, we can attain the third normal form, and those data only can be stored in the databases. So suppose here you can see drawing a data model diagram for data association sometimes helps analyze, appreciate the complexity of data stores. So this is the data model. What is the data model? Means how they are related. Here you can see salesperson number is related with the salesperson name and sales area, and again salesperson number is related to the customer number. And again, customer numbers is related with the customer name. Warehouse number is also related with warehouse location. Like that way, how the data model diagram can help the data analyst. So it is also important to understand how we can draw the data model. If the data were listed in an unnormalized table, there could be repeating groups. Like here you can see, there are repeating groups. A data model diagram shows that in the unnormalized relation, the salesperson number has a one-to-many association with some attributes. So here you can see, if data are not normalized, then you can see salesperson number has one-to-many relation with the customer number. Okay, which should not be there. And in that case only, we need to remove the redundancies or repeating groups to create a normalized one. So I will try to discuss about this first normal form or second normal form and third normal form in consequent videos and how we can do that. So before that, I advise you to kindly go through this context for better understanding, because we always need to normalize these things for better storage or for better designing of their databases, which is very, very important. Okay, then we'll again try to discuss how we can use or how we can design databases with this understanding about removing the repeating groups, removing the partial dependencies, removing the transitive dependencies. So if you have any doubt or confusion or any problem on understanding, please let me know. Whatever I have discussed, and I advise you to again go through it, the context of this book, to understand more and to gather more knowledge. So that's it about in this video. If you have any question, let me know. We'll try to resolve that over the Google Meet. Thank you.